Today, ladies and gentlemen, I'll continue with my text parser and I'll add some error handling. Because no matter how crazy the input to the parser, it should never give invalid output or crash or leak memory or anything like that. Let's try parsing some nonsense. Something like this. And see what happens. The tokenizer read fine, it doesn't care. But the parser is, well, confused. The first assignment has an assignment operator as its value. And the second assignment has no value at all. That's what I call not good. The parser can only process assignments, and an assignment always has to be text assignment operator text. So let's start at the beginning of this little state machine and see what I have. Well, the first token should be text, but it is an assignment operator, so that's an error right there. I'll keep track of the token that failed so I know where things went wrong. At this point, I could just stop parsing altogether, but let's see if I can make at least a bit of sense out of the input. The first token is wrong, so just skip that. But I can try again with the second token. Well, what do you know? This one is text. So I can go to the next step in our state machine. Now I'm expecting an assignment operator and I get not an assignment operator. Such a disappointment. Another error. If you look at the example, you can see that if I skip color and then try to continue, I'll miss a perfectly valid assignment. So I won't skip color. Instead, I'll just go back to the start of the state machine and try again. Color is text, so I go to the next step. Then I need an assignment operator, and that's what I have. So next step. I need text. What I have is text. Splendid. And now I have a complete assignment. Isn't it amazing? Even though the input text is all kinds of wrong, the parser does produce a valid parse tree. Well, it will once I've written the code. Alright, a parse error has two things. It has a type, and it keeps track of the token that caused the error. There's a limited number of error types, so I'll create an enum for that. I'm going to treat errors just like I did other output data, meaning I'll create the array in main, and pass it to parse, so that parse can fill it. If the first token isn't text, that's an error. Let's create current error here, and then I can fill it here. I expect the text. The current token is wrong. Done with this error, so I go to the next. And then I still skip the current token. Now, if the first token is text, I get to this part and assigning the key is no problem. I know I have the right token here. But then, after I go to the next token, I need to check if what I have is the right type. If it isn't, I register the error. And in this case, I don't skip the current token, but I just go to the next iteration of the while loop. And that will try to parse an assignment again, but this time beginning with the token that is definitely not an assignment operator. Of course, the value needs to be text, and if it isn't, that's an error. Now, since this token isn't text, it also can't be the start of an assignment, so I might as well skip it. Just abandon this assignment and try again with the next token. Let's give that a spin. 2 errors, as expected, and 1 assignment. Not bad. Well, I say that, but I'm pretty sure there's a bug there. Suppose the end of the input is like half an assignment. If I run it now, the errors are fine, but I get an invalid assignment, because when things go wrong, either here or here, I've already stored the key. So I shouldn't do that. Let me put the key in a temporary variable and then only store it when I know the assignment is fully correct. No result. Much better. There's not a whole lot that can go wrong in the tokenizer. If it doesn't recognize a character, I just skip it and the output of the token is still valid. But it would be nice to report invalid characters. A Tokenize error is slightly different from a parse error. It also has an error type, but it can't keep track of the token that failed since, well, I don't have any tokens yet. So instead, I'll keep track of the index into the ini text, so I can see which character caused trouble. The rest is pretty straightforward, really. Create the array in main. Pass it to Tokenize. Keep track of the current error. If I have an unrecognized character, then register the error. Next error, skip character. That's it. Let's do a little test. Wait, that's way too many invalid characters. Oh yeah, it reports whitespace as being invalid. Okay then. Well, don't panic, I can fix that. If a character is whitespace, then I just skip it. And I define whitespace as a space, or a tab, or some kind of line separator. Yes, that's much better. 2 invalid characters, but even so, I still have a valid assignment. Nice. And because assignments are always valid now, the memorizer actually can't go wrong, nor can the get function. Also nice. That's not to say that I can't think of any input that would break the parser though. How about this? See, small static arrays may be easy, but they are also static. And small. This input has too many tokens, too many assignments, too many entries, too many characters. Now, I know what you're thinking. You're thinking he's going to make the arrays dynamic and large. But no, because this part is not about fixing stuff, it's about handling errors. So what I'm gonna do is just report when there are too many tokens. I sense the risk of off by 1 error, so let's think this through carefully. Right now, the array I have has 8 items, because max tokens is 8. When the tokenizer starts, current token points to the first token. What I want to know is what is the address of the last token I can write to. If I move 8 tokens ahead, I'll be 1 past the last token. So the last token is current token plus 7, or max tokens minus 1. However, I'm using a sentinel to signal the end of the array. A sentinel is a token with all its values set to 0, and the parser uses it to know when there are no more tokens. Now, even if the token array is completely filled, the last item must still be a sentinel. In other words, the array can hold 8 items, but one of them must be a sentinel, so it can only hold 7 tokens. Which means that the last token is current token plus 6, or max tokens minus 2. Cool. Now that I know this, I can see that as long as current token doesn't exceed the last token, everything is fine. But when it does exceed last token, off to errorland I go. Okay, I start by calculating the last token. Then here is where I add a new token, so before I do that, I need to check if there is still room in the array. If there isn't, I report an error. And then there's nothing the tokenizer can still do, so I just break out of the while loop. Now I'll copy that code because here I'm adding the assignment operator token, so I need to check here as well. That should do it. Let's run it again, shall we? All the tokens are filled, the last one is still a sentinel, good, and I have a tokenize error. Too many tokens. I like. Of course, I also keep the errors in a static array, so I need to check that one as well. First, I need the last error. then whenever I add an error, here for example, I need to check if the current error exceeds the last error. If it does, well, then what? I want to record the error, but I'm out of space in the array of errors. I mean, that's what the error is. I guess I have two options. I could overwrite the last error. I'd lose an error I already detected, but reporting that there are too many errors is more important. Or I could move last error back by 1, and then it's fine if I write 1 beyond the last error. Either is fine, really. I'll go with the first one. Otherwise, when you're reading the code, it's why is it -2 for tokens but -3 for errors, and why are you writing after the last error? So the first option might be a bit more readable. Okay, then I can just replace the last error. Let's add that to the enum. And when that happens, the tokenizer shouldn't continue, so I'll break. Now, copy that code everywhere I write an error. Here and here. Boy, does this need cleanup. Not now, though. Create a test. Just add some invalid characters. And there you have it. Too many errors. The parser shouldn't be too different from the tokenizer. I can have too many assignments and too many errors. Determine the last assignment. And the last error. Here I create a new assignment, so current assignment shouldn't exceed last assignment. If it does, I report an error. And stop the parser. Before I report an error, I check if current error exceeds last error. If it does, I report too many errors. And stop the parser. I also need that check here, and here, and here. Change the test input. Let's see what happens. Lots of errors. Too many, in fact. Just how I like it. The entries in the memorizer are the same deal, except that the memorizer doesn't report errors yet. So first, a memorize error has a type and an assignment. There can be no error, or too many entries, or too many errors. Create the array in main. Parse it to memorize. Get the last entry. And the current error. And the last error. I create the entry at the beginning of the loop, so check if current entry exceeds last entry. If so, report the error. And exit the loop. Check if the current error exceeds the last error. If so, report. Break. That's it. To test, I need to allow more assignments, because the number of entries is always equal to the number of assignments. Run, run, run. Wait, why are there no errors? Did something go wrong in the parser? Expected assignment operator? Why does it only parse 2 assignments? Ah, okay, too many tokens. Yeah. Well, it proves the usefulness of error handling, I suppose. More tokens. And now there are too many entries. Good. But that's not the only thing that could go wrong in the memorizer. The string buffer also has a limited size. That one is a little bit different though. It doesn't really make sense to check for an overflow with every character, because then I'd most likely end up with half a key or half a value. So what I should do is calculate the length of the key and the length of the value, and then check if there's enough room in the buffer before I start copying. Now, the key and the value always include a null character, so color is actually 6 characters long, not 5. Same thing for white. If I take the buffer index and move it 6 for the key and then 6 for the value, I actually end up one place after the value. As long as the index is not larger than max buffer size, everything is fine. Note that the buffer doesn't have its own sentinel. The null character of the value is already a sentinel, I don't need another one. Okay, let's calculate the length of the key. +1 for the null character, and the length of the value. +1 for the null character. If the new index would exceed the max buffer size, report an error. And give up. Add the error to the enum. And check for too many errors. I'll just copy this. That should be it. I need a bigger test case. That underscore sure comes in handy right now. Buffer full. You don't say. Well, that's a pretty robust parser if you ask me. The code is getting a bit unwieldy though, so next time I'll do some refactoring. And I'll make the arrays a little bit easier to deal with. So subscribe if you want to stay up to date. A big thank you to my supporters on Patreon. You keep me going and it really makes all the difference. So thank you, and remember, coding is fun.